Hello everyone, how's it going? My name is Dan the Tutor, on a mission to become the world's greatest tutor. In today's video, we're going to be talking about dimensional analysis, which is one of the first things you learn in chemistry or physics, and it's because we basically use it a lot the rest of the school year. So basically what dimensional analysis looks like for really long problems, we have something like this, 3 grams of CO2, and the first conversion is 44.01 grams of CO2 and 1 mole of CO2. And if you're watching this video, you probably don't even know what a mole is or what molar mass is yet because it's still the beginning of the year. But the point is not to focus on the words I'm saying, just see a complex example of, well, basically how complex dimensional analysis can get. Anyways, this is moles of CO2 specifically, and then maybe for a certain equation we have 1 mole of CO2 and 3 moles of H2O. And then we wrap up this question by one more conversion factor, 1 mole of H2O with 18.02 grams. And basically I look at the units that cancel out. So for instance, the grams of CO2 cancels with the grams in the denominator here. Moles of CO2 cancels with the moles of CO2 down here. Moles of H2O here cancels with moles of H2O there. And I'm left with just grams here, and this is grams of H2O. And so anyways, the thing I want you to notice is that when done correctly, it looks like you're just crossing out all the way until you're left with your final unit here at the end. Now when it comes to plugging in the math in the calculator, these numbers you will multiply in the numerator, these 4, and then you will divide by these numbers in the denominator, which luckily 2 of these are 1, so I can just ignore any of the 1s. So it's going to be 3 times 18.02 divided by 44.01, giving me a final answer of 3.69. And in this case, the units are grams of H2O. And that's how we do dimensional analysis. So now let's do some examples of dimensional analysis in action. So the first problem I have 3 meters in length, and I want you to convert that into inches. Using the fact that there are 100 centimeters in 1 meter and 2.54 centimeters in 1 inch. So I'm going to do this first one with you. I start with 3 meters, and dimensional analysis basically boils down into conversion factors. What I mean by that is, the first one is this one, 100 centimeters equals 1 meter. I want to put 1 meter in the denominator and 100 centimeters in the numerator. And the reason why I want to do that is because meters will cancel out, leaving me with centimeters. And then for the second conversion factor, that's where I go from centimeters to inches. So here I'm going to put centimeters in the denominator this time. So again, it can cancel, and 1 inch goes in the numerator. So now all my units have canceled. I'm left with inches. And these 3 numbers are in the numerator, while the 2.54 is in the denominator. And after I plug that in my calculator, I get 118 inches. And there we go. That's how we do dimensional analysis. So now let's do a couple more. This next one's one of my favorites. I want you to convert 1 day into seconds using the conversion factor. 24 hours are in 1 day. In 1 hour, there are 60 minutes, and in 1 minute, there are 60 seconds. So go ahead, give this one a try on your own, and when you're ready to see the answer, unpause the video. So I start off with 1 day, and I'm going to have 3 multiplication factors this time. The first one is 1 day with 24 hours. The second one has 1 hour in the denominator to cancel out hours and 60 minutes in the numerator. And then the last one has 1 minute in the denominator with 60 seconds being in the numerator. And there we go. Looks like I'm just doing 24 times 60 times 60 to give me 86,400. And that is how many seconds are in a day. And of course you can count that on your own time, and you can count 1 to 86,400 And if a whole day has passed, then this is the correct answer. Or you can just take my word for it. And then for the last one we're going to do, this is going to be the hardest one. And I am going to tell you, this is a real chemistry example we're going to be doing here. Let's say I have 12 grams of CO2, and I want you to convert that to molecules of CO2 using the following two conversion factors. Number one, we have 44.01 grams of CO2 is equal to 1 mole of CO2. And it doesn't matter if you know what a mole is or not, but that's the conversion I want you to use. And then also 1 mole of CO2 is equal to 6.02 times 10 to the 23rd molecules. So go ahead, give this one a try, and when you're ready to see the solution, unpause the video. Okay, so first, 12 grams of CO2. I'm first going to multiply by 44.01 grams in the denominator with 1 mole in the numerator. That cancels out grams. And then I multiply by the next one, which is going to have 1 mole in the denominator and 6.02 times 10 to the 23rd molecules in the numerator. And then so it looks like I'm doing 12 times 6.02 times 10 to the 23rd, and then divided by 44.01. And that's going to give me an incredibly large number of 1.64 times 10 to the 23rd, and that is molecules of CO2, which is a number way higher than the largest number you can possibly think of, whether it's billion, trillion, quintillion, whatever. This is a ginormous number. But there we go. That's how we're going to be doing dimensional analysis in your science class this year. So if you do have any questions with that, please post them in the comments. If not, have a great rest of your day, and I'll see you in the next video. Take care, and bye-bye.